Hare Krishna. In this video, we are going to start with the first chapter of LDE. What is the full form of LDE? It is linear differential equations. Now, in LDE, we are first going to understand what is a complementary function. What is a complementary function? Of course, it doesn't matter if you understand, if you know what is a complementary function when we are going to solve sums. But if anyone wants to understand what basically is a complementary function, then a complementary function is a general solution of auxiliary function of LDE. That is the general definition of complementary function, and it is denoted by YC. Now there are approximately three types of complementary functions. Namely, the first case is a complementary function with different factors. Then the second case, it would be better if I could write it down. First case is different factors. In this equation, normally different factors are used, that is, no term is repeated. But if a term is repeated, then the complementary function, the case comes under the repeated factors. And the third case occurs when an imaginary term, that is I term, is used. It comes in the imaginary factors. Like 2i minus 2i, this plus minus 4i, likewise terms. Now starting with the first case, that is the different factors. We are going to write different factors. We can take an example like A. Assume D is equal to 2, 4, 6, 7, 9, minus 1, 1 by 2. Now this is the equation, these are the terms we are being given, and then somebody asks us to find the complementary function of this term. So first we have to determine that the factors are given in which case of the complementary function does this terms come. If we look closely here, not even a single term is repeated, so we can determine that this terms comes under the case 1, that is the different factors, that is each term is different from one another. So when different factors are used, what we'll write first, we'll count down the numbers that have been asked in the question. So 1, 2, 3, 4, 5, 6, 7. Total 7 numbers we have been given. So what we'll do, we'll write C1. We'll use some space here, plus C2 plus C3 plus C4 plus C5 plus C6 plus C7. And now we have to here C1 basically indicates the first term. Now, what is the first number in the sequence of numbers? The first number is 2, so we write e raised to the power 2x. Now here again C2 indicates the second term, and what is the second number here? 4. So we are going to write e raised to 4x. Likewise C3 indicates 6, so e raised to 6x, plus C4 it indicates 7, so e raised to 7x. C5, I think you have guessed it, it is minus 1, e raised to minus 1x. And the C6, oh, it is 9x, e raised to 9x. C5 indicates the fifth term, which is 9 here. Now C6 indicates minus 1, so e raised to minus x. And C7 at last indicates the last term, 7th term, which is 1 by 2. So here we will write e raised to 1 by 2x. I hope it is visible. We can also understand by solving another sum, like d is equal to 1 3 5 6 8 minus 1 minus 1 by 2 plus 2 by 3 minus 2 by 3. Now here if we look closely again, we can here write, yes, it's okay. If we look closely here, 1 and minus 1, they both are not identical, not same. The signs are opposite to each other, so they don't come under the repeated factor. If we look closely here also, 2 by 3 and minus 2 by 3, the numbers are same, but the sign here is given different. Here is plus and here is minus. So we can't say that the both the numbers are same, because the signs are opposite to each other. Their signs are not same. So we can, if we look again here, we can understand that not a single term is repeated. So we the whole term, the sequence comes under the different factors case. So as we solve the previous sum, we are going to solve this sum. YC is equal to, first counting the numbers, 1 2 3 4 5 6 7 8 9. 9 terms are given. So C1 plus C2 plus C3 plus C4 plus C5 plus C6 plus C7 plus C8 plus C9. What is the C1? What is the first term here? C1 indicates the first term, which is 1, e raised to 1x. C2, it indicates second term. The second term is 3, e raised to 3x. Likewise, e raised to 5x plus C4, e raised to 6x plus C5, e raised to 8x plus C6, e raised to minus x plus C7, e raised to minus 1 by 2x plus C8, e raised to 2 by 3x, and C9, e raised to minus 2 by 3x. So here is the final answer. Before solving the next two conditions, a little I'm going to say that anything raised to 0 is 1. Okay, e raised to 0 or a raised to 0 or e raised to 2 alpha 0, anything. If 0 is if anything invariable has a 0 as its raised to power, then we are going to decide that the answer is 1. E raised to 0 is 1. Also, if anything e raised to infinity is given, e raised to infinity, then we are going to decide that the answer will be 0. Okay, so now we are going to solve the repeated factors. I hope visible. Repeated factors. How are we going to decide that the sequence number of term sequence we have been asked is repeated? We are going to understand by solving this following sums: 1 comma 1 comma 1 comma minus 2 comma minus 2 comma minus 2 comma minus 2 comma 3 by 4 comma 3 by 4. Okay, so here if we look, 1 is repeated 3 times, minus 2 is repeated 4 times, and 3 by 4 is repeated 2 times. And also the sign that each term here, that the sign they have is also same. Like here 1 forms a group of 3 where the sign, both of these 3 terms have the same sign. Here minus 2 is repeated 4 times and minus sign is common between them. Minus minus sign and number 2 is common. Here 3 by 4 is repeated 2 times and both the signs are same. So first looking at the one term, focusing on the first 3 numbers which are repeated, we can write it down as we did in the previous example. We are going to write the first term as C1, second term as C2. So the first term we are going to write it as C1, then again we are going to leave some space, then C2, and then again we are going to leave some space and C3, and then we are going to close the bracket. Now 1 is repeated 3 times, so we are going to write here x and we are going to write here x. As 1 is repeated 3 times, so the highest power which we are going to take is 3 minus 1, which is 2. 1 is repeated 3 times, so here the highest power we are going to take is 3 minus 1, which will be 2, and then we are going to decrease the power. Here will be 1 and here it will be 0, so we don't have to write anything here because as I said, x raised to 0 is equal to 1 and C3 into 1 is equal to C3, and at the end we are going to write e raised to what is the term here, what is the term that is repeated? Number 1 is repeated, so e raised to 1x. Again we are going to solve the second group. Minus 2 is repeated 4 times, so we are written up to C3, so now C4 represents a 4 term which is minus 2, so C4 plus C5 plus C6 plus C7. Here again we are going to write x, x and x. As here the highest number, the number is repeated highest times as 4, The maximum number times it is repeated is 4. So 4 minus 1, which is 3. So the highest power which will be first write is 3. Then the number goes on decreasing. We are going to write here 2, then here 1, and then here 0. And as the number repeated is minus 2, so then we are going to write e raised to minus 2x plus, again, so 3 by 4 here is repeated 2 times. So as the last number we have written is c7, so this is the 8th term and this is the 9th term. So c8x plus c9. And what is the highest term, maximum number of times 3 by 4 is repeated? It is 2. So 2 minus 1, here 1, and then here it goes on decreasing. So 1 minus 0 is 0, and anything raised to 0 is 1. What number is repeated? 3 by 4 is repeated. So we are going to write here 3 by 4. This is the final answer. We are going to get a final idea by solving the final sum. D is equal to 0, 0, 0, 5, 5, 5, and 3, 4. Now again, as we look, two numbers have been repeated. 0 is repeated thrice and 5 is also repeated thrice. So this whole equation comes under the repeated factors, excluding these two terms. These two terms are not repeated. These two terms are different from all of the other terms. So now what we are going to solve is first focusing on the 0 term which has been repeated thrice. So C1, C2, C3, C1, C2, C3, x, bracket complete. Now the highest maximum number of times it has 0 has been repeated is 3. So first we are going to write here power 3 minus 1 2, then the power will go on decreasing, 2 minus 1 1, and then it will be 0. Which number is repeated? E raised to 0x plus again c4, c5, c6, c4x plus c5x plus c6. Yeah, again 5 has been repeated 3 times. The maximum number of times it has been repeated is 3. So 3 minus 1 2, and then the power goes on decreasing, 2 minus 1 1, and again 0. Which number has been repeated? 5. So in the last we are going to write e raised to 5x. And now here these both terms are not repeated, they are different. So as we have solved in the previous sums, we are going to write c7 e raised to 3x plus c8 e raised to 4x. This is the final answer. The third and the final case of the complementary function which we are going to learn now as the imaginary factors. How we are going to understand the terms we have been asked is an imaginary function. It is let's assume 7i minus 7i. Now we can also write the both terms as a single term, because 7i both are repeated, only the there is sign difference of plus minus. We can write it as, it's only applicable to the imaginary terms, don't do it to other terms where I is not present. So plus minus 7i. Now we are going to compare the following with imaginary term which is uh, d is equal to alpha plus minus beta I. By comparing we will get alpha. What is, we should understand what is the beta term here. Beta is the term which is associated directly with the I. So 7 here is beta, and again alpha is the separated term which is not associated with I. So we can see here that no number is associated with I, so we can assume that then alpha is equal to 0 and beta is equal to 7. Alpha is equal to 0 and beta is equal to 7. So we are going to write the formula is yc. For imaginary terms, the complementary function for imaginary factors, the formula is e raised to 0x bracket e raised to alpha x then bracket c1 cos beta x plus c2 sin beta x. E raised to alpha, as the value of alpha is 1, so we are going to write e raised to 0x c1 cos beta. Here for for the value of beta is 7, so we are going to we can see that there is plus and minus 7 here, so we are going to assume only positive sign for beta. So cos 7x plus c2 sin 7x. We can further evaluate as anything raised to 0 is 1, so the final answer will be c1 cos 7x plus c2 sin 7x. This is the final answer. Now by solving this final sum, we'll get a concrete idea about what is how to solve imaginary terms, imaginary factors or complementary function. Now when this question has been asked, we can easily understand it is an imaginary function because I is present here. Wherever there is I, we can understand that the term is imaginary. So we can write these terms as 3 as it is, and here plus minus under root phi I. Okay, and now comparing it with d is equal to alpha plus minus beta I to get the values of alpha and beta. Now what is the value of alpha here? The value of alpha, the term which is not associated with I. 3 is not associated with I, so value of alpha is 3. And what is the value of beta? The term which is associated with I. So it is root phi. We all know for imaginary factors the formula is y is equal to e raised to alpha x c1 cos beta x plus c2 sin beta x. Putting the values in their respective places, e raised to alpha, what is the value of alpha? It is 3. E raised to 3x bracket c1 C1 cos, what is the value of beta? Root 5 x plus C2 sin root 5x. This is the final answer because further there is no evaluation. So I hope you have understood sincerely. If there are any problems or fault in the making of this video, you can please comment in the comments section below. Hare Krishna.